Okay, good morning, good afternoon, good evening to everyone, wherever you are watching this tutorial from. This tutorial is simply a revision in preparation for the upcoming supplementary exams, which are scheduled to be on the 23rd of November. So we shall use a number of past papers to revise through, but as usual, we are sticking to the first two, which I'm sure I communicated to you, the major two papers we have to focus on in preparation for these supplementary examinations. So I'll start with the deferred sessional exam paper for 2025, which is this year, the deferred paper which was written this year. So we'll run through each and every question, and then after that we'll look at the main sessional exam paper for this year, and then if we have some time we can also look at something else as well. So this is how we are going to move in the preparation for this supplementary examinations. So we'll start with the deferred. I'm sure I'm able to project something there. Hopefully we are able to see through. So I'll start from question number 1. So remember, we're trying to revise, and this stage, we know we cannot start teaching each other, but we'll be able to just remind one another what each concept mean. So even as we are solving through, we are just trying to remind each other, because in just 20 days it's impossible for us to teach the whole course outline. But the only way the only thing we can do is basically simply remind one another and revise through what we can. So that is our paper there. So we'll start from question number 1 without wasting time. So question number 1A is simply coming from the concept of sets. So the question says that let A and B be sets such that the number of elements in set A denoted by a number of elements in A equals to that, and so forth. And then we are being told to say find the number of elements in A intersection B. So what are we having here? We are looking at question number 1, supplementary example. I hope this is the correct spelling for supplementary. I don't know if it's on that twice for some of us, even number spellings. So question number 1A is talking about let the number of elements in A be equal to 20, the number of elements in B be equal to 26, the number of elements in A union B is equal to 34. And what are we looking for? We are looking for the number of elements in A intersection B, which we do not know. So every time when we have such issues in terms of sets, such questions involving sets, I always emphasize on something. Number 1, identify how many types of sets do you have in the question. So if you look at the kind of question which we have here, we have only 2 types of sets. Two sets. We have set A and set B there. So these are the only sets we have. The rest are just basically operations which can be involved between set A and set B. So once you know the 2 types of sets, therefore, next thing, what are you supposed to do? You have to be able to recall the inclusive and the exclusive principle. So they recall the inclusive exclusive principle, which says that if we have 2 sets A and B, then the number of elements in A union B is simply equal to the number of elements in A plus number of elements in B minus the number of elements in A intersection B. So somehow this is the main equation or the main operation when it comes to the inclusive and exclusive principle when involving 2 sets. So set A and set B can be joined by this kind of operation which we have here. So this is more like the main equation where sometimes you can have the union being told to find the A, you can have the others being told to find B, you can have others being told to find the intersection. So this is more like our main equation. So this is where, if you look at my previous lessons, I always emphasize that if you look at either set A and set B being joint or disjoint set, that's how it's going to affect this equation. So if let's say it's a disjoint set, then it will no longer have any intersection. The intersection will be a 0. Then the inclusive principle will just end from here because the intersection is 0. There is nothing intersecting A and B. But if there is something intersecting A and B, then the whole equation becomes complete until this point. So what are we looking for? We're looking for the number of elements in A and in the intersection part. So we have the union, which is 34. We have A, which is 20. We have B, which is 26. And we're looking for the intersection right. Then the next is just basically you performing what? Algebra there. So 34 is equals to 20 plus that. So this is 34 to be equals to 20 plus 26. I believe this is a 46 minus the intersection A intersection B. This goes to the other side, becomes a positive number of elements in A intersection B. We have 46 this side. When this one crosses to the other side, becomes negative 34. So that we can have number of elements in A intersection B to give us 46 minus 34. That's how much? 6 minus a 4, that's a 2. 4 minus a 3, that's 1. This is our final answer. So for question 1A, we are being told to find the number of elements in A intersection B. Our number of elements in A intersection B is equal to a 12. So that is our final answer for question 1A. So in case of a question on says something to do with that, be able to recall the inclusive and exclusive principle. Let's go to the second part of the question 1. So let's go to the second part. We're now looking at question 1B. Question number 1B. I'm sure the question is visible. B is talking about something which is a situational question there. It's application on non-linear functions. So we have to basically understand, even every time you read something, be able to understand, so what kind of question is this? This is an application of non-linear functions, something to do with exponential functions, logarithmic functions, and so forth. So the question says the population in thousands. So every time you are reading such a question, pay particular attention to every statement and every word. So here we have the question which says we have the population. So this population, if you look at in bracket, it has already been stated that the population should be in thousands. Sometimes they will say, no, the population is in millions. Sometimes they will say the population is in hundreds. So be able to pay particular attention to that. Of the city of Ndola on the Copper Belt province from 2010. So starting point, we're talking about from 2010 way up to through 2017. That's according to the statement there. Through 2017 can be modeled by, so the model equation which is connecting this is basically P, which is the population, is basically P, which is the population, to be equal to 200, E, which is the Euler number, power, K, which is the constant value, T, which is the time taken. And sure, even the question says where T represents the years, with T equal to 0 corresponding to 2010. So T represents the years, with T equal to 0 corresponding to 2010. So what are we having here? In short, we're simply saying that in 2010, our T is equals to 0. That's what we know. And then there is something there which is trying to help us. What is helping us there is in 2015, the population of Quito was about 850,000. So let me just take down this data here. So I simply saying in 2015, we have the population to be equals to 850,000. That's the population. So it is this information. So every time you have such a question, so in the statement, there must be some information which is going to assist you to find the value of this k. If the model has been given without the value of k, it means that the first stage before you do anything, you have to basically find this value of k there. K is basically a constant value. This constant value does not change. It is the same throughout. As time goes by, but the constant k remains the same. It is constant. So there must be some information in the statement, in the question, to help you find the value of this constant k. So once you find the value of that constant k, by default, it will assist you to answer any kind of question which will follow through next. So with this information, the information in 2015 is what is going to help me find the value of k. So in 2015, we are being told that this p is equals to 850,000. So in 2015, if t is equals to 0 in 2010, so the task is, what is t in 2015? So if 2010 is t equal to 0, it's more like our initial value, our launching point. So t equal to 0 in 10, obviously in 2015, what is the value going to be? So put it in a situation whereby we're talking about, let's say we're talking about, this is 2010, we can have 2011, we can have 2012, we can have 2013, we can have 2014, we can have 2015. Let's say if we were to break it in that manner. So what am I having? If this is the year, we are going to have t there. So our t is going to be, in 2010 we have 0. When we go in 2011, obviously our t is going to be 1, because it is counting there. As years goes by, the t is basically what? Increasing. So in 2010 our t is equals to 0 because it's the year of the launch. In 2011 our t is equals to 1. In 2012 our t is equals to 2. In 2013 our t is equals to 3. In 2014 our t is equals to 4. In 2015 our t is equals to what? To 5. If you do not want to get confused, you can break it down in that manner. So if you look at the pattern, how do I find this value of t? If my initial year is 2010, then t in 2015, then t in 2015 can be equals to what? 2015 minus my 2010. Automatically the value of t, if I say 2015 minus 2010, what am I going to have? It's going to be equals to a 5. This is the same 5 which is there. So once you know the initial year, then the initial year there t is equals to 0. So wherever year you are standing at, just basically say the year you are standing in minus the initial year to find the value of t. Then you are well and good. So what is this information helping me to do? Helping me to find the value of k. Remember, what is the first question saying in this statement? Use the model. Where am I? Find the value of k correct to 2 decimal places. We are finding the value of k correct to 2 decimal places. So it means we are using the information for 2015. So in 2015, this is our population. And this is our t value. Then we will be able to find the t, replace t value, replace the p value, and find for k. So this is what we are going to do. So what am I going to have? Now, before replacing the p in the model, take note of this statement which says the population is in 1,000. So if the population is in 1,000, I'm not going to enter the whole 850,000 here, but we are going to discount this, or maybe basically break this down to suit the model. So this is the actual population, which has been said that we have about 850,000 people. But for me to enter the 850,000 in the model, it's supposed to be broken down to suit this model. So it means we have to eliminate 1,000 because this model already suits the population which says it's in thousands. So the 1,000 should be this should be divided by 1,000 for me to have the actual population which can enter into the model. But if there were not this statement of in 1,000 was not indicated, then p value is going to acquire the whole 850,000. But since there is this statement in 1,000, then we divide the p by 1,000 for it to enter the population. So meaning that p equals to 200 multiplied by e power kt. When we replace upper the p, we divide this by 1,000. If we divide this by 1,000, we're going to have our P to be equals to 850 to be equals to 200 multiplied by E, which is our Euler number. We don't know the value of K is what we are looking for. We have T, which is equals to what? Which is equals to 5. So it means 5 times K, we're going to have 5K there. This is how our model is going to look like. So what is our next stage there? Our next stage, it is basically to find the value of K. So this is why your calculators need to start working now. So we want to find the value of K. So let's find the value of K. Obviously, the first stage will be to delete this 200, divided by 200 there, divided by 200 there. This goes. It means that I'm going to have 850. 850 divided by 200, which will be a 4.25. 4.25 to be equals to E power 5K. So these are exponential equations. Now remember how we were solving exponential equations. So we have K there, which is our variable. So how do I solve for K? How do we solve for K? Obviously, the only way this power can come down is introducing a certain force on both sides. So it means we're going to have something like natural log on both sides. So I'm going to have the natural log of 4.25 should be equals to the natural log of E power 5K. So that according to the rule of logs, this can come down to be 5K natural log of E. We still have the natural log of 4.25 this side. Now, what is the natural log of E? The ln of E is basically a 1 because this is a log of this E. Ln of E is basically a 1. So 1 times 5K will still remain to have a 5K. This side will still remain to have the natural log of 4.25. We want to find the value of K. It means we'll divide both sides by 5, even this side by 5, so that this value of K can now be equals to natural log of 4.25 divided by 5. So you punch in on your calculator natural log of 4.25, natural log of 4.25, okay, natural log of 4.25. The answer we divided by 5. Oops. The calculators we are using. Do I have a normal calculator? Okay. So natural log of 4.2. So natural log of 4.25 divided by a 5. Confirm. I don't trust this calculator which I'm using. So according to me here, it's saying that the value of K, which I have, is basically 0.289. That's the value of K I have. But let's look at the question. The question says correct to 2 decimal places. So it means that I have to end on 2 decimal places. So this is greater than 5. So 1 will go to the other side, meaning that my value of K is going to be equal to 0.29. This is my value of K. So our value of K in this case is basically 0.29. That is our value of K. So it is through the value of K you can be able to tell whether the population will be increasing or basically decreasing. So what is going to happen here, as time goes by, the population will be increasing because the value of K is a positive value. So in the model here, K is positive. So if K is positive, then the population will be increasing. But if K is negative, then the population will be what? Decreasing. That's one thing you have to understand. We can also confirm when we'll be finding the population, let's say in 2014, that the 2014 will have a bigger population compared to 2015 because K there is positive. So that is our B1. So the value of K is 0.29 and the population will be increasing. So let's look at Roman numeral 2. The question says, use the model to find the population in key for key 2 in 2014. So let me delete this part. Where can I delete? Okay, let me delete this part. So if you look at now, since we found the value of k, then our model is now complete. It's going to be equals to 200 e, our k is 0.29, so 0.29 multiplied by t. This will be our complete model now. We are going to use. So now use the model to find the population in Kitwe for 2014. So in 2014, so this is B. In 2014, we can start by finding the value for t. The value for t in 2014, we are starting in 2014 minus the initial in 2010. So automatically, our value of t, if we subtract, what are we going to have? I believe we are having what? 2010 to, is it a 4? It's a 4, right? Oh, actually it's 2024, sorry, in 2024. So in 2024. So if we subtract 2024 minus 2010, we are going to have 4 minus 0 is 4, 2 minus 1 is 1, the rest is 0, so it's 14 years. So t is equals to 14. Then let's find the population now. So we are going to have p is equals to 200 multiplied by e power 0.29 multiplied by t is 14. So we'll start by multiplying the power first. So we're going to have 0.29 multiplied by 14. So I don't know, I don't trust this calculator, it's showing blank. So this says p is equals to 200 multiplied by e. If I multiply this times that, I have 4.06. You can confirm, don't trust this calculator. So we are simply saying the whole number e power that power 4 point I have something like 57 point that, and then multiplied by a 200. I have something like p is equals to 11594. I think there's a point somewhere. 86 222. I think so. My calculator is not simply visible. Let me just confirm again. So let me confirm for the second time. So we have power 4.06, yeah, multiplied by 200. So 11594.86222. So that is the population. So now this is the population which is in the model. Now when interpreting, the question says find the population in the equation in 2014. So the population now is going to be what? So the population will now be equals to, remember we said the population should be what? In 1,000. So this is the one thing which is coming from the model. So when interpreting, therefore, in 2024, population will be equals to, so this is for the model. So if this is for the model, we multiply this by 1,000 for us to interpret the kind of population which is in 2024. Remember in the first place we said if we're entering the population in the model, we divide by 1,000. But if we're interpreting the population for that year, we multiply that population which is coming from the model by 1,000. So we multiply this by 1,000. So if we multiply this by 1,000, obviously it will be 1, 2, 3. So we're going to have 1, 1, 5, 9, 4, 8, 2.22. This will be the population in 2024. So that will be our population in 2024. So we multiply it by 1,000. We're okay. And then we shift to the next part. We shift to the next part. The next part is us now finding, according to the model, which year will the population reach that? That is 5,650,000 population. So in which year are we going to experience that? So we still go back again to the model. So this is 2, we go to 3 now. So this can be deleted. So what am I going to have? This is Roman numeral 3. So this is Roman numeral 3. So Roman numeral 3 says, in which year? We are finding the year when population is 5,650,000. When that is our population. So we use the same model. So model is P is equals to 200 multiplied by e power 0.29 t. So replacing, what is our P? This is our population. But for this population to enter the model, we divide it by 1,000. So dividing this by 1,000, if we divide this by 1,000, we're going to have 5,650. The zeros goes to be equal to 200 e power 0.29 t. We want to find the value of t. So it means we divide by 200. We divide by 200. This goes. We'll remain with. We have 5,650 divided by 200. Boom, 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 boom. So this is, we are going to have 28.25, if I'm not mistaken. 5,650 divided by that, we're going to have 28.25 to be equals to e power 0.290. Confirm, I don't trust my calculator. So applying logs on both sides, because the e here is the power, so we're going to have the natural log of 28.25 to be equals to the natural log of e power 0.290. So that, according to the power rule, this will drop. We're going to have 0.29 t natural log of e. This side we still have a natural log of 28.25. So this is still a 1. Natural log of e is 1. So what do? Divide both sides by 0.29. Even this side 0.29. So that if we say natural log of this divided by 0.29, we are going to have something approximately. So this goes, let me write it from here. I have something like t is approximately 11.52. So approximately, the question says, if that is time, then the question says, which year will the population reach that? So approximately 11.52, we're trying to approximate that as something like 12 years from now. So t is approximately 12. Therefore, in which year? If the initial year here was 2010, we add 12 to 2010. What are we going to have? If we add 12 in 2010, then the year we are looking for here will be 2010 plus 12 which will be equivalent to 20, this is 2, this is 2022 as the year when the population is going to reach 5,650,000. So that's what we are going to have. So the year will be in 2022. So according to which year? The year will be in 2022. We are okay? Let's go to the second question. Let's go to the second question, C. There. Okay, so we have the second question there, C, question 1C, which says that solve the equation log 3x plus log 3x minus 8 equals to 2. So those are logarithmic equations. First stage, be able to remember some of the properties on logs. So make sure you remember the properties of logs. It is the same properties which are going to assist you in solving such logarithmic equations. So first thing is first, simplify that as a one log. So you have to simplify that as a single log. That's the first stage. Simplify as a single log. What do I mean by a single log? I don't want to see two terms there. I just want a one term thing. So I have to simplify it as a single log. The only way that can be simplified is basically remembering some of the properties on logs. So recall that if I have the log of base b, a multiplied by b, this is basically the log of base b a plus the log of base b b. If in the input here there is multiplication, it changes to a summation. If the input here was a divided by b, then this becomes log of b a minus the log of b b. So this is what I'm going to use. So I'm seeing the same bases here, base 3, but different inputs. It means this came from a what? A multiplication part. So what am I going to have? I'm going to have log 3x plus log 3x minus 8 can be written as the log of 3 in brackets here it is x multiplied by x minus 8. That is what is going to happen because these two are basically coming from a summation, multiplication, summation thingy. We are okay? So we are going to use this, which is a single log. So therefore, what we are simply saying here is the log of 3x minus 8 is now equals to a what? A 2. So we are solving now this equation. This is the equation we are now going to solve. So we want to find the value of x. So how do I find the value of x? Every time we are solving logarithmic equations, at least be able to remember the properties. And one thing which is going to help you find the variable in a log equation is to know how to convert from logs to exponential form. So we're going to convert that from a log form to exponential form. This is the base, this is the input, and this is the output. So converting this to exponential form, what are we simply saying? Base power output should be equal to the input, implying that 3 power output should be equal to the input, which is x minus 8. Something like that. Automatically, when something becomes like that, it now becomes very easy to solve. So let me delete just the top part so that we can now start it nicely. So we've converted this to that. So we're going to use this to solve the value of x now. We are okay? So let me delete this part. So what are we having here? We are having, I love starting with the variable, so I can write it as x minus 8 to be equals to 3 squared. So if I break down this becomes x squared, expanding the bracket, breaking down the bracket, x times x is x squared, x times this is negative 8x is equals to 3 squared is a 9. 9 can come to the other side, becomes x squared minus 8x minus 9 to be equal to 0. Becomes a quadratic equation, very much simple to solve. If I was to even leave it here, I believe we can solve. If I was even to leave it here, I believe we can solve. So x squared minus 8x minus 9 is equal to 0. Can the product sum and factors work out here? The product sum and factors, 9. Product sum and factor, can it work out? Sometimes if it can't work out, I always go for the formula method, because I know the formula method will always solve anything. This is what? This is 9. 9 can be broken down into 3 times 3. It can't work out with it. So automatically we're going to have x can be equals to negative b, positive or negative, the square root of b squared minus 4ac over 2a. The over starts from here to the far end. So if you know that the factorization fails you, after your school of business you always use calculators. Formula method works out. So negative b, this is negative 8, positive or negative, negative 8 squared minus 4, a is 1, c is negative 9 over 2. So that the value of x can, because this is now positive 8, positive or negative, the square root of 8 is 64. This is 9 times 4. 9 times 4, that's 6. I don't know. 9 times 4. 36, yeah. So this is 64 plus 36 over 2. And 64 plus 36, that's how much? That's 100, huh? So we're going to have x is equals to 8, positive or negative, the square root of 100 over 2. So square root of 100 is 10, implying that, I don't know if I can be able to write it from here. So my board is very small. So implying that x can be equals to positive 8, positive or negative 10 over 2. So the first value of x can be equals to 8 plus 10 over 2, or 8 minus 10 over 2. So that x can be equals to 18 divided by 2, that's a 9. 8 minus 10, that's negative 2 to be, or negative what? That's negative 1, eh? Yeah. So these are the values of x. So we are simply saying x is equals to 9 or x is equals to negative 1. So these are the two possible values of x. Now, since this is a logarithmic equation, I'm sure even the factorization method could have worked out for the fact that we have x, 9 and negative 1. So two numbers were supposed to be 9 and negative 1, if I'm not mistaken. 1 minus 9. Yeah. So, since this is a logarithmic equation, we have to understand that for it to be a logarithmic equation, obviously it's not all values of x which can satisfy the equation. So what do I have to do? We have to test those values. So which one? Look at the domain. If you look at the domain for this function, if I was to say, what is the domain for this function? Can I delete the... Okay, let me just delete this part. If we say, and look at the domain for this function, we are simply saying whatever should be in the input should not be negative or 0. So if I say x is equals to negative 1, what is going to happen? If I put negative 1 here, this will be a negative input. If I put negative 1 here, this will be a negative input, making this function to be undefined. But if I put a 9 here, this will be valid. If I put a 9, this will be valid. It will be a positive value. If we even test log 3 there, if I put a 9 there, this will be 3 minus a 1, which is going to give us a 2. So automatically x equals to negative 1 is invalid. Why is it invalid? Because if it is negative 1 here, it makes this whole function to be undefined. In the input, we shouldn't have a negative input. So therefore, x is equals to 9 is the only value which you need in this equation.